basic differentiation rules and rates of change. Let me make this comment before I began. I went back and looked at some of my previous videos and I saw myself scooting up in the beginning of the video, which made me look like I was, I don't know, weird, of which I am kind of strange. I was doing this. I don't know if you remember seeing that at the beginning of almost every video. Well, let me tell you what that was, because I went back and looked at myself and I said, what are you doing? So actually what I was doing was, at the beginning of the recording, I'm trying to scoot up in my chair close to the screen so I can see and write on the screen for you. So that's what that was. So I am weird, but I'm not, okay, that creepy. Anyway, a few things here. The neat thing about this section and beyond is that we can use a very simple formula to calculate the derivative instead of having to use the limit definition, which is very long. The first is, if you think about it, the derivative represents the slope. So the derivative of a constant function is 0, and obviously that is the case, because if it's a constant, that means it's a horizontal line. So y equal to c is horizontal. And every horizontal line has 0 slope, because the slope for a horizontal line, there is no rise divided by the change in x. So we get 0. The power rule, most important for the derivative formula. Here, if the function is equal to x to the n, then the derivative is n times x to the n minus 1. If y is equal to x to the negative 6, comma, y prime is equal to negative 6 times x to the negative 6 minus 1 is negative 7. And we don't like to write the result with a negative exponent, so this is negative 6 all over x to the 7th. The constant multiple rule, that if you have a constant multiplied to a function, the derivative is simply the constant, which is factored out, times the derivative of the function. So if we have a function, and say for example, if, now I'm going to write it different than how they're writing this, but I think you'll get the point. If this is 12 times x to the third minus 6 times x squared plus 17x minus 25. Now here the constant is the 12, the negative 6, and the 17. So f prime of x is the 12, which is held fixed, that's what they're saying here, times the 3, based on the formula, times x to the 3 minus 1, which is 2, minus 6 times the 2 times x, and this is 2 minus 1, which is 1, plus here the derivative of 17x is just 17, because the derivative of x is 1. The derivative with respect to x of x is equal to, think about it, this is x to the 1 minus 1, x to the 0, we get 1. Then the derivative of a constant is 0, and we can clean that up and just write this as 36x squared minus 12x plus 17. The sum and difference rules for the derivative. Here the derivative with respect to x of the sum is equal to the sum of the derivatives. Again, the derivative of the sum is equal to the sum of the derivatives. The derivative of the difference is equal to the difference of the derivatives. In like manner, when we talk about the derivatives of cosine and sine, and then later on we'll talk about the derivatives of cosecant, cotangent, and secant. But here we start with these two, and they are the foundation. From these two derivatives, we can build all the rest of the trigonometric function derivatives. So the thing that you want to know is that the derivative of sine is equal to cosine, and the derivative of cosine is equal to negative sine x. Now, just a simple way of how I keep this in my head is that anytime I take the derivative in terms of trig functions, if the trig function starts with a c, like cosine, cotangent, cosecant, the result, the derivative is always a negative, right? And if the term is not starting with a c, like sine and tangent and secant, then the result for that derivative would not be negative. Okay. Let's look at some problems. Let's take the derivative here. So we say y prime is equal to 7 times x to the 7 minus 1 is 6. We're going to rewrite this problem and write this as y equal to x to the negative 5 to be able to use the formula. So y is equal to negative 5 times x to the negative 5 minus 1. So here we get negative 6. And you want to write this where the exponent is positive. So this is negative 5 all over x to the 6. Rewrite this function as f of x is equal to x to the 1/5. So the derivative, f prime of x, is 1/5 times x to the 1/5 minus 1. So this is 1 over 5 times x to the 1/5 minus 5 over 5. That's negative 4/5. So you can write this as 1 all over 5 that's the 5 here, times x to the 4 over 5. S prime of t is equal to 3t to the second plus 5 times 2 is 10. T to the 2 minus 1 is just t to the first minus 3. Again, the derivative of a constant is 0. Here we take y prime. So we get pi over 2, which is a constant, or here a coefficient or a multiple, a multiplier. So it stays there, times the derivative of the sine theta, which is cosine theta. The derivative of cosine theta is negative sine, so this is negative times a negative. We get plus sine theta. Here in this problem, find the slope of the graph of the function at the given point. Use the derivative feature of a graphing utility. Blah, we don't need that. Just find the derivative and just plug in x equal to 2, and you find the slope of this function at that given point. So we rewrite the function as 8 times x to the negative 2. We find its derivative, f prime of x, is equal to 8 times negative 2 times x to the negative 2 minus 1, which is x to the negative 3. And so we write here f prime of x is negative 16 all over x to the third power. And then here it says evaluate the function, the derivative at x equal to 2. So f prime of 2 is equal to negative 16 over 2 to the third. So this is negative 16 over 8. And all we have here is just negative 2. That's the derivative. Moving on, find this derivative. So f prime of x is equal to 2x. The derivative of 5 is 0. And then this is minus 3 times negative 2 times x to the negative 2 minus 1 is negative 3. So f prime of x is 2x plus 6 over x to the third. Now for this problem, let's rewrite it. These terms are divided by x to the second. So x to the third over x squared can be simplified minus 3x squared over x squared plus, I'm going to write this as 4 times x to the negative 2. F of x, simplifying, this is x minus 3 plus 4 times x to the negative 2. So f prime of x is equal to, the derivative of x is 1, the derivative of negative 3 is 0, and this is 4 times negative 2, just write it, this is negative 8 times x to the negative 3, and then we can write this as f prime of x is equal to 1 minus 8 over x to the third. Find this derivative, but we're going to rewrite this as x to the 1/2 power minus 6 times x to the 1/3 power. Take the derivative now. F prime of x is equal to 1/2 times x to the 1/2 minus 1. That's negative 1/2. Sorry, I got that 1/3 in my head. I'm looking at that, working that in my head, and doing this at the same time. So I slow down. This is 1/2 times x to the 1/2 minus 1 is negative 1/2 minus 6 times, here we multiply by the 1/3 times x to the 1/3 minus 1. 1/3 minus 1 is 1/3 minus 3 over 3. That's negative 2/3. And so we can write the derivative here as 1 over 2 times the square root of x minus 6 divided by 3 is 2, and this is all over. A couple of ways you can write this. You can write this as x to the 3, that's 2/3, or you can write this as the cube root of x squared. And it doesn't matter, right? So I wrote it like that to match up with this form here, but obviously you could have written this as, this is 1 over 2 times the square root of x minus 2 all over x to the 2/3 power. So again, either way you write that, it's fine. Determine the points, if any, at which the graph of the function has a horizontal tangent line. So I'll just take number 57. All they want us to do is to find the derivative, set it equal to 0, and at those points the graph is said to have a tangent, a horizontal tangent line. We understand here by setting y prime equals to 0 denotes that the derivative it has a horizontal tangent line at the value of x. What did I just say? It was pretty neat. By setting y prime equal to 0, the function has horizontal tangent line at okay. Well, let's see. And maybe I can just graphically show you. Let's check this out. What if I can draw straight? That where the graph tops out or bottoms out, that's going to be, corresponding to the so-called x value. But here, the derivative is 0. Well, let's see. Let's see. Y prime is equal to 4x to the third minus 6x. Right. This is factor out of that's a 4. 4x. Factor out of 4x. And we have left x squared minus 1. Setting y prime equal to 0 implies that 4x times x squared minus 1 is set to equal to 0. This implies that x is equal to 0 and the x squared minus 1 is equal to 0. That is, x is plus or minus 1. So the values of x that you have for the horizontal tangent line would be x equals 0, x equal to 1, x equal to negative 1. Right? That's not a good way of writing that. How about that? Find k such that the line is tangent to the graph of the function. What they're saying is that if you have a function, does the line touch the function? And if it does it touch it at a point? And if so, can you manipulate k to make it happen? Because we don't know where this parabola is. We can identify the line, right? So let's see. What we do is we find the derivative of the function, which is negative 2x. We set the derivative here to be equal to the slope for the line. All right? We're going to try to connect these two functions. And m is equal to -6 from y equal to -6x plus 1. So setting the slopes equal, remember this is a slope as well, the derivative. So set the slopes equal and solve for x. So when we do that, we have -2x is equal to -6. We get x is equal to 3. So if x is equal to 3, then we know that the function and the line, they share a common point of 3. So since x equal 3 is a common point for both equations, this implies then that if I plug in x equal to 3, I can set the equations equal at x equal to 3. So this implies that k minus 3 squared is equal to -6 times 3 plus 1. Well, this implies that k minus 9 is equal to -18 plus 1. So we get -17. And this implies that k is equal to 9 minus 17. So here, k is equal to -8. That's what my grandmama used to do when something wasn't right. She's watching the news, something Jimmy Carter said, president back then, or Ronald Reagan, whatever. She'd say, thought that was always a funny thing when I used to see that. Number 64, we do the same thing. So here we find the derivative for the function. So this is 2kx, and over here m is equal to -2. We set them both equal, and then it kind of gives us a bit of a challenge. So this implies that 2kx is equal to -2. Well, the only thing that we can do for this guy is to look at this and say that k times x is equal to -1. But I'm going to go a little bit further. I'm going to go ahead and solve for x. X is equal to -1 over k. And it's at this point, x equal to -1 over k, that the function and the line would share a common value. So I'm going to replace now x with -1 over k, set the two equations equal. Set them equal, so I get k times x squared, but x squared is -1 over k to be squared. That's equal to -2 times x, but x is said to be -1 over k plus 3. Simplify there, get the value for k, and you get the answer. So this is, yes, k over k squared is equal to 2 over k plus 3. So this is 1 over k is equal to 2 over k plus 3. Subtract 2 over k on both sides, so you get 1 over k minus 2 over k. That gives me -1 over k is equal to 3. And multiply k on both sides, divide both sides by 3. You get -1 over 3 is equal to k. So k is equal to negative 1/3. And oh, by the way, let me see if I take this problem. Forgive me, I didn't just do a graph so that at least we have a visual. Please forgive me. Oh, should be fine. So we got this parabola, and at k we got to be negative 8. That guy is way down there. I need to correct my graph. I can try to make that a little bit straighter. More stuff is happening down here. Don't mean to take too much time. Here, the function is negative 8 minus x squared. So I find negative 8. Let's just say it's here. And then it's a parabola that's doing that. And then this graph here is negative 6x plus 1 has a y-intercept plus 1. They're going to meet at x equal to 3. So at x equal to 3, y is equal to negative 6 times 3 plus 1. So y is equal to negative 18 plus 1, negative 17. So y is going to be negative 17. X is 3. So it's going to be 3, negative 17. They're going to be touching there. Somewhat. So here the y-intercept is this guy. That. Okay, I missed it. That's what my wife said. No, I'm just joking. I don't know what that means anyway. I gotta go through this point and touch this curve, right? Maybe right there. My parabola is off. Dang on parabola. But it's okay. And now it looks like I'm going through the origin, and I'm not. You know, it's that dang on crazy parabola. I hate parabolas. Why don't you get a computer program and let it do it? Who trusts computers? Oh, you're taking a web class. Okay, we like computers, right? Maybe do that first. Now watch, I can't even get the cuckoo parabola to act right. Yeah, I guess it wouldn't be good to take your pistol and shoot the computer. Okay. That's what they're saying. Sorry, it took me forever and a day to get there. But you get the idea, right? Yeah, you don't want to see me sit here all day and try to graph this guy as well. But I think I can do it quickly. Just do a sketch of it. So the value for k came out to be negative. So this guy, oh great, is going downstairs too. So we get that. And then the line. This guy touches a little bit closer up, so straight line, right? Okay, let's look at this guy, this last problem, and we're done. So we find this derivative. First, we rewrite f of x. This is k times x to the -1. And I didn't edit that out. I just wanted you to see how, we're all the same, right? Even sometimes I can't get it right. That's fine. So this implies that f prime of x is equal. I do not mean to take all this time, believe you me, but this is -1 times k is -k times x to the -2. Now for this equation, the slope is equal to -3/4. So we set the slopes equal. Now when we do that, we have -k times x to the -2 is equal to -3/4. Simplify. This is -k over x squared is equal to -3/4. Multiply by negative through, and then we'll multiply x squared on both sides, multiply 4 on both sides. So this implies that 4k is equal to 3x squared. Now, when you simplify that, we get x to equal, to be plus or minus. But the only one that works is going to be the positive value. So here we take the square roots of both sides and then dividing through by that 3 as well. So this gives us the square root of 4k all over the square root of 3. That's x. And so this is 2 times the square root of k all over the square root of 3. So I set the equations equal. I have k over x is equal to -3/4 times x plus 3 at x equal to this. So I replace x with that information over there. So this is k over x, and x is 2 times the square root of k over the square root of 3, and that's equal to -3/4 times x, and x is 2 times the square root of k over the square root of 3, and that's plus 3. Simplify this. This becomes k times the square root of 3 over 2 times the square root of k, and that's equal to -3 times the square root of k over 2 times the square root of 3 plus 3. We can do some simplification here. That is, we can do some rationalizing, if you will. So we'll rationalize that square root of k downstairs and rationalize that square root of 3 right here. So this becomes k times the square root of 3 times the square root of k. So this is k times the square root of 3k all over 2k. It's equal to, this is -3 times the square root of 3k all over 2 times 3 plus 3. Keep simplifying that. And the k's cancel out there. So this is the square root of 3k over 2 is equal to, the 3's cancel, this is negative square root of 3k over 2 plus 3. We add this term to both sides, so that gives us the square root of 3k is equal to 3. Square both sides, we get 3k is equal to 9, k is equal to 3. What do you think? I'm done. I held you too long. Thank you.